Hi, my name is Cosmin and I'm going to talk about workers group in Central. So by the end of this video, I would like you will have a better understanding of what is a Russ, what exactly is a worker, how to run an operation on a particular worker, how to group multiple workers together for redundancy and not only, how to run an operation on a group that contains different workers, how to create a flow that has operations that run on that each run on different workers, and how what is group alias in Studio and how you can use it. Right. Okay. So RAS is in Studio. So a RAS is a remote action service that contains a worker and a remote protocol for connecting with Central, right? Also, a RAS is an instance of an OO component and enables execution in remote data centers and networks. A RAS can be used if HPOO needs to run flows in a network segment that is not reachable from the HPOO central node. In such cases, you can install a RAS instance in the target network segment, and it will pull the required flows from the central and run them locally. Okay, another use case here would be is where a RAS can be used when the flow requires specific binaries on the local machine. There is no need to install binaries on each HPOO node. It is enough to install them on a host where RAS is installed and configure the flow or specific step to run on that RAS. This can be achieved by leveraging the worker group functionality, which I'll describe later. So basically, RAS is a component of the operations orchestration, and it's as the name says, remote action service. So usually you can actually run this in remote networks. Okay, worker groups. Worker groups are software components that are responsible for executing flows. A worker connects to Central to obtain tasks, flow execution messages to process, right? That's a worker. For example, Central has a worker, Studio has a worker, and also RAS has a worker. And basically this is what executes the flow. It's the worker that executes the flow or the operation. Now, what exactly are worker groups? There can be multiple workers, for example, in a specific environment. And the group is a collection of, it's a logical connections of workers. And one worker, for example, can may belong to more groups simultaneously. I'm going to show you this later, but now I would like only to give you more like how it. I would like to let you know exactly how this works in high level, and to give you an understanding of what I'm going to show you later. Right, now group aliases, basically this lets you separate between using an operation to a worker during authoring time and the runtime environment. So for example, you know that there are different personas in OO. One persona author might not be the same persona as the admin, and with group aliases you can define the author can define a group aliases that an admin can map to a group, right? And from that group it can run on certain workers. Okay, basically that's the whole idea of group analysis, to separate between the author and the groups that are available in Central. So as I mentioned, in Central, the administrator maps these aliases to the actual worker group. So, for example, an author can create the flows without actually knowing on which exact worker will this flow run. Right? That's the idea of it. Right. Okay. So this is high-level representation. So you have an operation, you assign an alias to it, that alias is mapped to a group, and that operation that was mapped to a group will run on any of the workers that are inside that group. That's the concept here. Now, next, why the question is, why would someone want to run an operation on a specific worker? Now, there are multiple responses here. One is that it needs to run an operation or a flow on a specific remote network where the Russ is part of. So, for example, someone has Central in one network segment and Russ in a different network segment, right? So if you want to run an operation in that network segment, you would need to run it from a machine from that network, right? And this is exactly what it does. So if a Russ is installed in that network segment and you choose that Russ, you will be able to run the flow or operation on exactly that network segment. Another option is to run uh, exactly on a flow or operation on a specific flow, because some operations are written, for example, in .NET. So this needs they need a Windows host in order to be able to run. So, for example, .NET operations will not be able to run on Linux RASes, right? So that's the idea here. So yeah, okay. Now, why use worker groups? Basically, why would someone use worker groups? Now, as I said, you can combine multiple workers in a group, right? So the idea is that in this way you can handle big execution loads, and you can also have high availability by using this. So many deployments can benefit from having more than a single worker in a specific environment. For example, this could be useful if you are managing a remote data center in which you need workers to be able to withstand the action execution load, or simply for high availability, as I said. And so, as I said, the group is a logical collection of workers, and the workers may belong to one or more groups simultaneously. Having a worker group prevents bottlenecks, because the step can run on any of the workers in the group. So, for example, if, let's say, worker RAS4 from this picture is full of running, then RAS5 will come into and pull jobs from Central to run this. So actually it helps making it helps preventing bottlenecks, right? Okay, so now I'm going to show you a live demo of exactly how you can achieve this, by showing you first how you have an operation in Studio, how you create an operation in such a way that you can run it on a certain worker, how you can create an operation so that you can run it on, so for example, you create a flow that has operations that each runs on different workers, and just an easy way to map them so according to your specific needs, but this is more like a high level of how you can do. Obviously you will be able to do a lot more. Okay, so first I would like to show you my environment that I have. So as you can see, I have two Linux RASes here, and for Windows workers, one is Essential and three are RASes. These three are RASes, and this one is Essential worker, as you can see. Okay, and you might know this already. The default group that it's created in Central is Russ operator path. So this you will see every time you have a new instance of OO, you will see this Russ operator path. So this applies to every operations and flows, because if this group would not be here, an operation would not know on which worker to run onto. Right. Okay, so I have Studio as well here, and I'm going to show you, for example, different flows, and we will test them to see how we can run them in a different way. So obviously this might not apply for everything that you would like to do, but it will give you an insight of how you can use this to leverage your environment and see how it will better suit you. So first I'm going to I have here a flow, any group operation. So it's a basic flow that we do not specify on which worker to run onto, right? It's just simple. It will run on whatever worker it is, just normal flow. I have here another flow that uses system properties. Okay, so first let me clarify exactly what is an override JRUS and in an override NRUS, right? Okay, so let me open this as well. Now, an override JRUS is the override group that that operations belongs to. As you can see here, so override JRUS means that this operation was created with Java, right? That's the basic idea here. And there are two kinds of operations, those created in Java and those created with .NET. Those created with .NET, their override group is override and Russ, as you can see here, and the action name it tells you that it's a .NET web action, and this one is it's not a .NET, so it's obviously a Java operation. Okay, so one idea is that, so if you have a flow that's the basic thing that has one operation, right? It could have multiple operation. It's just a demo flow. If we provide an input override JRUS at the flow level, right? In this way we can we create a variable, and that variable will be used to override this one. So for example, we know that this is an override JRUS, right? And by using this variable we can tell that this operation, this flow actually will run with the constant value on the specific group that will be in central. So let me show you what exactly I mean. So first, this is how you declare a variable in Studio, and the value of this variable is specific worker, right? So actually what this will do, this operate flow will run on the specific worker. Now we need to create this specific worker in Central. And how do you create a group here? Okay, so first let's create the groups, and then I'll show you how you can map what I input in Studio to the groups here. So first, let's create a Linux group for these two Ubuntu servers. That's it. You can see it now. Besides the Russ operator path, you also have the Linux for these two Ubuntu machines. Okay, so let's create a Windows group for all these Windows machines. Okay, apply. Okay, and now let's create a network. Let's create another group in which there's only one worker, right? So all of these are workers, and let's create a group that contains only one worker. So we have this reverse Russ, and let's put this reverse Russ in another group called the specific worker. Right. Okay, so and now let's create some let's put some complexity in here, and also create another group that has both Linux and Windows hosts, just to see how this will work. And we'll call this network A. Okay, now let's see exactly what we have here. So we have Linux machines that are part of the Linux groups, also part of the default Russ operator path groups, and one Linux machine is part of the network A group. And here we have the Windows machines, we have a specific worker group, so this group contains only one worker, and this is this reverse Russ. And we also have another group, network A, that, as you know, is part of the both that has both Windows and Linux Russes. Okay, and now if we move to Studio, as I said, we are using here, you'll see why we are using system properties, is because the admin, which is most of the time not the same as the author, will be able to modify the system properties once they are in Central. So as I said, we have the specific worker, and if I have the same name, the specific worker here, and the same name, the same group name, specific worker in Central, OO will map this automatically, and will know that this property value refers to that Russ group in Central. Okay. Okay, so I'll show you how you can create this in Studio. Now we are going to use only Linux machines. Let's say we have a flow that we would like to run only on the Linux machines. So for this we would need to map for the override JRUS, we would need to map the Linux work group, right? Okay, so this is how you do it. You have an input at flow level, and you just give the name of the group. And as I said, central O will know to map this to the central group. Okay, now another flow is we would like to run this on network A, right? On network A group. There are two, as you can see here, we have the group aliases and the system properties. Now in this example, so I've shown you how to use system properties. I'm also going to show you how to use group aliases. So I said that in OO you can have multiple personas, right? An author and an admin, and most of the time it's not the same person. And so you can have this group aliases map to the workers group, to the worker groups in central if it's the same name. So this is exactly what I'm doing here. So I'm using the network A group alias that will map to the network A from central. So this is for network A, and here we have only Windows. We want to run this only on Windows hosts machines because we know this is .NET operations and we cannot run it on Central. Now, in order to move faster through this process, I've already created a content pack from Studio, and I've imported it to Central. And I have here the operations under production A, and as you can see I have here the any group operation, any group op, and I'll just run it and see. We haven't assigned any worker. We'll see where exactly this will run. Okay, let's see. Okay, it just run, and step details. Okay, so the worker ID is FFB. That applies to this one. So as it seems that this was the default worker that got that flow running. And as you can see, we have here the worker group that run these two operations. So these two operations were run in this worker group, Russ operator path, which is the default one. Okay, now let's run to see how we can run with the system properties, right? So I said that for example we have a system property name and the value of this system property is found here, and we see that the system property specified worker has the deployed value of specific worker. Now what I said is the advantage is that this can be modified with any value. So for example, if you want to modify the worker group name, you can just specify here and also modify it in here, right? So that's how you do it. That's the advantage of using system properties here. Okay, so let's see. Let's run the second flow with system properties. Okay, let's run it from here. As you can see, I've added this input at flow level, and it should run on only the specified version, the specified worker, which is this one. Let's see if this works. Right, so we have this specific worker, FFB. That's okay, that's fine. Right, now if we go, let's say we have a flow and we want to run it on only on the Linux hosts, right? And we've already mapped the Linux workers, the Russ Linux workers on a group that's called Linux, right? Let's see how this flows looks like. Okay, let's run it and see if it run only on the Linux machine. Okay, let's show full tracking here. Worker group Linux, worker ID 4C3. Let's see which one is this. Oh, it's the second. Okay, so these two operations run on the on this Ubuntu Linux server, right? Okay, we now want to run a flow on a network that has both Linux and Windows machines, right? And so we've mapped a group called Network A that will run on that network where it has both Windows and Linux hosts. And I've shown you that you can use this value, this input name, override JRUS. We know it's a Java operation, and we give this variable name network A because as I've shown you here in group aliases, I've created a group alias with the name network A. So this is how you map a group alias for your flow in Central, right? And if we run it, it should run on the network A worker group. Okay, so it says there are no worker assigned to network A. Okay, let's see why is that. So we have network A and we have network A here. Let's see why. Let's debug this and see exactly why this not work. Okay. Let's run it like this. Okay. So it's resolved. Let's see. So it's run on worker group network A, right? Okay, and it's EF6. Let's see, EF6. Oh, sorry, it's the step ID. The worker ID is AEA. AEA is this one that has network A in the name. So the idea is that when you map this group aliases, you don't need to have it as a variable. It already knows it if you have this group aliases with this name. Right, so that was my mistake here. In this way you've seen how to troubleshoot this. Okay, and the last operation that we have here is Windows only. So I have here the operating system. Let's see exactly which operations I have, which operation I'm using. I'm using the ping command. It's a .NET command, and as you can see, the override group is an override and Russ. In this way I have to create a new input at flow level that's an override JRUS. Let's see. I've created this override NRUS, right? That's for .NET, and I have the Windows group aliases. I also have this group aliases. I also have the group Windows, sorry, and this will map with the group aliases that's also called Windows. So any of these window workers will be able to run this operation. Okay, let's see. Okay, let's run it. And see how it's run. Okay, so we have the worker group Windows and the worker ID 44. Let's see which one starts with 44. So is this one. Now let's make another test and see what happens if for example I have except of the override and Russ, by default I assign it to, by mistake I assign it to a Linux group, right? So in this group there are only Linux workers. Let's see what happens here. It will return an error message saying that this should not work for Linux hosts. Okay, we have the error message: fails to execute content, .NET Web Action plugin, execution failed, reason, and there's an exception there. So you've seen that this is how you can map a flow or an operation to run on a specific group or on a specific worker. Now these are obviously basic use cases, but by using this principle of applying worker groups and group alliances, you can create very complex scenarios that might apply to your environment. Okay, so now to recap exactly what you've learned, what you've hopefully learned from this video. So you should know by now what are workers and what is their role. You should know how to use the worker groups in Central. You've seen how to create ones and how to assign workers to that group. You should know the difference between group alliances and workers groups. So one is to map what the author did to what admin expects to have, right? So there's a difference between these two. By default, if it has the same name or knows that it should connect them, it should link them. You've seen how to define each operation flow on which worker to run onto, right? You've seen how to create a flow that has multiple operations that all run on separate workers. Okay, so I don't think you've seen this. Let me go back to this and I'll show you how you do this later. Just to finish, how an author can create flows, making sure the flow run on specific worker without the author being aware of the name of the worker. Right, so that's how we've run one operation. Okay, so let me now show you how to run an operation, a flow that has operations to run on different Russes each. Okay, so let me show you the flow. So we have two operations. We have one which will run on Windows Rus, and one which will run on a Linux, on a different Rus. Now what I've did here is that so this operation is an operation that I've created by copy from this dependency to projects. So I've actually duplicated this operation and created a so-called hard copy. Okay, and I've assigned a different group alias, which is called network A, by doing this. Okay, this is how you change group alias for an operation. You can only do this for this kind of operations where you can where you've created a hard copy, right? You cannot do from this from the content pack. You won't be able to do this. For example, here you can see. Let's see. Nope. Okay. Okay, so we did this, and this will run. This operation will run on network A group. So we'll run on the group alias network A that maps with the network A from central. Okay, and this one will run by default on whatever worker it's available. So let's run this. Okay. Okay, let's see what happens. Okay, so let's see. First operation on worker group network A, 85cc. Let's see which one is this. So this is the worker that ran the first operation, and the second is the same, but in this case it's the same, but it's on a different worker group. So you would be able, so if Russ operator path would not, so if this worker group would have not been part of the Russ operator path, you would have two different workers here, but you can see that there are different worker groups. Okay, so this sums up my presentations on worker groups. Hope you enjoyed it, and hope you've learned how to run an operation on a different worker, or on a worker that you choose to run it.